Okay, so let's just go ahead and get started real quick. We're going to do a simple vector addition problem to get started. Let's just go ahead and assign some. Yeah. And you can't even find it anymore. I don't think you can buy it on DVD, and Yahoo TV is no longer a thing, so who knows. Let's just go ahead and assign some, and let's bring it back one. Okay, and let's say 2, 3, 5, and 6. How to pick those numbers, I'm just making stuff up as I go, but that won't stop us from being able to solve for what we need to, okay? So, how's the sound and everything? I'm trying out a lavalier microphone, and I've got the webcam and everything typed up. I would normally play some classical music in the background, but the last time I did that, it got muted because one of the songs was misattributed. But oh well. So we can imagine that this would be set up on a quiz or a test in some way, where we'd have somebody walks 6 something north, 5 something to the right, 3 something to the north, 10 something to the west, and 2 something to the south. Okay. And what we are looking for is this guy right here, the hypotenuse that I just drew of my imaginary right triangle. Okay. So what we need to do first is we need to figure out how long these sides are for A and B, so that we can find out using our Pythagorean theorem exactly how long our displacement really is from where we started to where we ended up. And afterwards we'll figure out how to calculate that angle as well. Okay, and so we got our north, east, south, and west over there. But anyway, so let's get started. The way I like to do it, and this is just the most explicit way. There's lots of ways to do it. There's lots of things that will feel more natural to you, and feel free to go ahead and do it. But this is the way I do it, and there we go. So because the x and y axes and everything in that direction, neither one interacts with the other, we can consider them separately. And as a result, what I want to do is I want to add up everything that's in the x direction, and then separately add up everything in the y direction. Okay, so we have a 5 and a 10 that go in our x direction. We only have those 2 pieces. Now, I've deliberately left something out so that you can consider it briefly, but our 5 and our 10 are headed in different directions, which means one of them must be negative. Does it matter which one is negative? It really, really does not matter which one is negative. It just matters that one of them is, because they're pointed in different directions. Let's see if it turns the light on. Seems better. Or does it just seem oddly blue? Okay, there we go, much better. All right, so we have 5 plus negative 10, or a negative 5. Okay, that's going to be our A over here, our total displacement in the x direction, or delta x, if you will, and delta y. So in our y direction, we have 6, 3, and as we've pointed out before, a negative 2. Okay, so 6 plus 3 is 9, plus negative 2 is positive 7. So this is our A and this is our B, and frankly they could be B and A, it doesn't matter. But now that we've figured out the length of each side of our triangle, we can use Pythagorean theorem, a squared plus b squared equal, or a squared plus b squared equals c squared, to solve for the length of our resultant vector. We have negative 5 squared plus 7 squared equals some number squared. Now, a few things that we can expect about our answer before we start doing any more of the calculation is that our c will be bigger than both 5 and 7. Okay, so if you end up getting a c that's somewhere in between your a and your b, that means you made a mistake, because it's by definition the hypotenuse is always the longest side of the triangle. Okay, so negative 5 squared is 25 plus 7 squared, which is 49, equals c squared. So 74 equals c squared. Okay, so 6 squared is 36, 9 squared is 81, and 8 squared is 64. Nothing's really close, but we know it's going to be somewhere in between 8 and 9. So 74, square root of 74, equals 8.6. Our c is equal to 8.6 whatever units. I didn't give us units before. So 8.6. Okay, there we go. But, like I said, we want to go ahead and calculate that angle. L, students, this is where you would end. And you'd be able to say that your direction was at northwest because it's pointed that way. So that would work out good. But for my K students, let's go ahead and figure out this angle. Now the tangent of our angle, and I've marked which angle that I'm going to be searching for, is equal to the opposite side over the hypotenuse, or opposite side over the adjacent side. Now the opposite side from this angle is B over here, so B, and our adjacent side is A, right there. So we can rewrite our equation as tangent of theta equals our B, which in this case was 7, and negative 5, because that's our delta x in that way. Now that we have a ratio, we take the antitangent of both sides. We do tan negative 1 of 7 over negative 5. And before we do any of that stuff, we degree mode. Everybody, all the time, everywhere, all day, degree mode. Unless we're doing radians, but we're not. So antitangent of 7 divided by negative 5. And that gives us 54 degrees. Okay? So that means it's 54 degrees, but on the left side of our axes. Now we can either consider it as all the way around that way, or we can just say that it is 54 degrees, 54.5 degrees north of west. Both of those things are equally correct. Let's go ahead and zoom in and